Assalamualaikum warahmatullahi wabarakatuh and good day. My name is Muhammad Hamizan bin Muhammad Hafiz. My matric number is 211093370. Okay, I will talk about introduction. For the first point is project scope. The group project focus on electrical installation design for a mosque and two-story office building in Malaysia. The next point is importance of design. Importance of design highlight the crucial role of effective electrical design in ensuring efficiency, reliability and safety in complex building project. They emphasize the necessity of proper electrical design for functionality and sustainability, especially in fluctuating buildings like mosque and office space. Work method consists of planning, design and simulation phases using industry standard method for evaluating schematic design for accuracy and reliability. Efficiency and safety. A mosque electrical installation design must ensure efficiency, safety and adherence to applicable laws and standards. Power distribution, wiring system and cable sizing. For power distribution, guarantee adequate power distribution, appropriate voltage regulation and compliance with electrical codes and standards. For wiring system, assess various wiring system like bus bar, cable tray or conduit based on ease of installation, flexibility and safety. For cable sizings, determine the size of sub-main cable. Adheres to all applicable electrical codes, safety standard and local regulation. For safety measures, incorporate measures to mitigate electrical hazards, proper grounding and overcurrent protection. Focus on the health and safety of users, conforming to local and national electrical codes. Okay, I will talk about project. Okay, this project is about assignment 3 and assignment 4 in this subject. Assignment 3 more to how to control the energy usage, while assignment 4 more to calculate voltage drop like efficiency, safety and compliance. Okay, next slide is about objective. First, for objective 1, provide schematic diagram. Offer exhaustive schematic diagram for all necessary distribution board, which we call DB. Reduce energy usage, minimize energy consumption through efficient design, increase operational safety, enhance safety in the electrical system operation, ensure cost effectiveness, implement design that are financially viable, improve system reliability, use separate DBs for lighting, electricity and air conditioning to enhance system reliability. Enhance load monitoring. Use hierarchical distribution method to improve load monitoring and isolation. Last, for objective 1 is optimize power factor. Improve power factor efficiency to reduce energy losses and electrical bill. Like ensure comprehensive compliance, meet regulatory regulation while respecting cultural values. For objective 2, point number 1, ensure efficiency, safety and compliance. Adhere to applicable laws and standards. Next, optimize voltage regulation. Ensure appropriate voltage regulation. Meet load requirement. Calculate load requirement for lighting, power and air conditioning. Adhere to electrical code. Comply with local and national electrical codes and safety standards. Enhance safety and well-being. Enhance safety and well-being. Improve the congregation, community safety and well-being. Last point for objective 2, comprehensive compliance. Comprehensive compliance is ensure the design complies with all standard and regulation considering societal, health, safety, legal and cultural aspect.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shakir Farhan bin Fahmi Rizal. My metric number is 2110909661. Today I want to present about flowchart for assignment 3, which is have three different of flowchart. Firstly for the distribution board, second sub switch board, and lastly for the MCB. For the DB distribution board, firstly start, second refer to table to calculate the light socket and AC, third calculate the total maximum demand and rating current, fourth finding rating current for MCB, RCCB and MCCB, fifth drawing the connection in the plant based on the calculation, and lastly is N. For the sub switchboard SSB, firstly start, second calculate total connected load TCL and maximum demand MD, third calculate design current, fourth finding rating current for MCCB, fifth number 5 drawing the connection in the plant based on the calculation, and lastly N. And lastly for the flowchart is MCEB. Firstly start, second determine total connected load line TCL and maximum demand MD for sub switch board SSB, third calculate the design current, fourth finding the rating current for the MCCB, fifth calculate the power factor correction, which is a PFC, sixth drawing the connection in the plant based on the calculation, lastly N. Justification of load. Ground floor, I take the example for the MD lightning. The MD lightning maximum demand is 25.518. For the MCCB lightning based on the JKR is 30 ampere, and the RCCB lightning based on JKR2 is 30 ampere. And then for the first floor, maximum demand lightning is 20.107 ampere. For the MCCB lightning for first floor is 30 ampere, and the RCCB lightning for the first floor is 30 ampere. Then for the Mosque, the maximum demand lightning is 21.156 ampere, and then for the MCCB lightning for the MCCB lightning for the Mosque is 30 ampere based on the JKR, and then lastly for the RCCB lightning is 30 ampere based on JKR. Next example assignment 3 calculation. In the left side is the formula, which is have two formula, which is design power factor correction and the protection requirement. QC is the required capacitor output in kVAR, P is the real power in kilowatt, theta 1 is phase angle of the actual power factor, theta 2 is the phase angle of the target power factor, cos theta 1 is the actual power factor, for the cos theta 2 is the target power factor. V nu is the supply voltage that capacitor is required, F nu is the frequency the capacitor is required, Q nu is the capacitor output at the V nu and the F nu, VCN is the rated capacitor voltage, FCN is the rated capacitor frequency, QCN is the rated capacitor output at the VCN and FCN. Economic design in electrical installation. Purposeful selection of component. Component chosen: lightning, power socket, AC, sub switchboard SSB, power factor correction board PFC, and the main switchboard MSB. Criteria: cause effect without compromising effect or safety. Next is analytical process. Step 1. Analyze power need of each board considering load and distance, which is 100 meter from MSB to SSB. Step 2. Calculate cable size using standard electrical formula, which is the 4% voltage drop assumption. Next is the cable selection. The load estimation: determine the current load for each board based on the anticipated power use. Cable choice: smaller gauge for the lower power needs like lightning DB, large gauge for the higher power demands like a air conditioner DB. And next, the environmental consideration ensure insulation and heat resistance of the cable. Material decision, which is the choose copper cable over aluminium for better conductivity and durability despite higher initial cost. Decision based on the total cost of the ownership analysis, which is the maintenance, energy and losses. Compliance and safety. Followed relevant electrical codes and regulation to meet safety standard. Next, the cost estimation. Project monthly electrical bill based on the calculated load and local tariff rate. Include power factor correction to reduce reactive power and increase system efficiency. Lastly, documentation and verification, which is the detailed document and ensure transparency and ease of verification, balance economical efficiency with reliable performance for an optimal electrical installation system.
Assalamualaikum. My name is Muhammad Nazim bin Muhammad Nasir. My matrix number is 211090951, and I would like to present about project flow chart assignment 4. Step 1. We have to start the project, and explanation for the start project is the project begins with determining by voltage drop and the distance, and second step is determine voltage drop and distance, meaning the voltage drop is set to 4% from the voltage supply and the distance from the MSB to SSB set to meters. And the third step is calculate the VD and distance, and the fourth step is determine the cable size. Fifth is select sub-main cable for DB, and the sixth step is determine wiring system. The seventh step is designing wiring system for the DB, and the eighth step is finalize cable selection and wiring design. And then last step is end the project, and it means project is completed with the finalized cable selection and wiring system design. For the selection cables, we pick two types of cables. First is multi-core armor 90 Celsius thermosetting insulated cables. It used at SSB 3 from MSB at the most. The installation method is direct in ground or inducting in ground, in or around buildings. The method that we use is method D, and the datasheet we get it from table 4E, 4A and 4E, 4B. And the second one is single core 70 Celsius thermoplastic insulated cables, non-armor, with or without sheath. The installation method is enclosed in conduit on a wall, on tracking and etc. The method we use is method B, and the datasheet we use is table 4D1A and 4D1B. This is the calculation assignment 4 that we use in our report to calculate in our Excel. Okay, the formula is VD equal to R cos theta plus X sin theta close bracket times IB times length divided by 1000. Okay, the second one is percentage voltage drop, three-phase system equal to VD divided by 400 times 100. For the third one is voltage drop percentage for single phase equal to VD divided by 230 times 100. For the description, VD equal to voltage drop, R equal to resistance, we get it from datasheet, X equal to reactance, also we get it from datasheet, cos theta equal to 0.85, sin theta equal to 0.53, IB equal to current that we got from Excel, and the length is we have to calculate the distance from the drawings. This is for our economic design for assignment 4. Okay, the first one is wiring and sub-main cables. Explanation for that is chosen for lighting. power air conditioning sub switchboard or aka SSB, power factor correction board PFC, and main switchboard MSB based on cost effectiveness, efficiency and safety. And the second one is power need analysis, means started with analyzing each board's power needs, considering load and distance from the MSB. And the third one is cable sizing. Use electrical formula to determine the right cable size for a 100-meter distance and a 4% voltage drop. And the last one, and the fourth one is load calculation. Estimate each board current load based on anticipated power usage. And the next is cable selection. Smaller cables for low power lighting DBs, larger cables for higher power air conditioning DBs. And the next one is material choice. Choose chopper cables over aluminium due to better conductivity and durability. Okay, the next one is regulatory compliance to ensure adherence to electrical codes and safety standards. The last one, cost estimation.
Okay, last slide is about conclusion. Conclusion 1. Conclusion is about project importance, highlight the critical importance of efficient, safe and culturally sensitive electrical infrastructure. Meticulous planning, emphasize meticulous planning and adherence to regulatory standards. Industry standard method. Industry standard method implements industry standard method like distribution board (DB), protection measure and power factor correction. Economic design, balance upfront expenses, long-term savings and system reliability. Environmental sustainability, support environmental sustainability and societal well-being. Community benefit, aims to benefit the community by encouraging safe, dependable and environmentally friendly electrical systems. Ethical and sustainable development, sets a standard for ethical and sustainable infrastructure development in Malaysia and abroad. For conclusion 2, efficiency, safety, compliance. First thing first, complexity of design. Acknowledge the complexity of designing a mosquito's electrical installation. Focus on efficient, safety and regulatory compliance. Wiring system assessment. Wiring system assessment, assess various wiring system for flexibility, ease of installation and safety. For cable selection, unique needs and safety measure. For cable selection, select cable that meet strict safety and performance requirement. For unique needs, consider the mosquito unique needs and environmental factors. For safety measure, include measure to mitigate electrical hazards, ensure proper grounding, and provide overcurrent protection. Also ensure installation meets all legal and regulatory requirements and utilize energy saving techniques and sustainable practice. For cost effectiveness, prioritize cost effectiveness without compromising performance or safety. Consider also the temperature, humidity and exposure for corrosive materials in cable and wiring system choice. For comprehensive design, ensure the design consider efficiency, safety, legal compliance and cultural consideration. For last point is long-term benefits. Long-term benefits improve safety and well-being of the congregation and community with a stable and secure electrical infrastructure. Thank you. That's all from me.